Hello, 5 seconds later, we're back. I need to finish this example from the notes and maybe talk a little bit about the second example too as well. So we were just talking about, the limit as x approaches 4 and the function at 4. Now I'm going to talk about a through d. What happens when we seem to have an asymptote type situation, not only here as a vertical, but it almost looks like we've got a horizontal asymptote going over here. So I'm just going to keep that in mind that there is an intended horizontal asymptote right here, and there's an intended vertical asymptote right here. All right, so the limit as x approaches -7 from the left. So here's our function. Here's -7. Here's left. Yes. So from the left, our function is getting closer to the axis, but it's a body of water. We're never going to cross it. We're never going to cross it. It just keeps going forever, up, 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 always. That just means that we're dealing with an infinite y-value situation. It doesn't actually ever stop. So it approaches the behavior of positive infinity. And by the way, that's kind of what calculus is based on. Like, we're talking about like infinite mathematics now, and that's why this is sort of like under the umbrella of calculus. What about -7 from the right? So this was -7 from the left. From the right of -7, we're talking about this part of the curve here. So from the right, -7, we're trying to get to x equals -7, but it will not cross, it will not cross. It is stuck just going forever downward. Negative infinity. So, we talked about this. The limit at a specific spot is sort of like two people are driving along the function's curve, one from the left, one from the right. It exists if they map to a specific spot from the left and the right. Now, here's a mistake a lot of people make. They see that there's this point, this dot at y equals 1, 2, 3. And they say, well, this is a weird situation. I guess the limit equals 3 there. It does not equal 3. Here's why. This driver will never converge with this driver. I mean, they are forever heading in opposite directions. So if you have two drivers that are forever heading in opposite directions, then they will never meet, which means that the limit will not exist at that spot. A good rule to go by is that limits just straight up don't exist when you have infinite left-right limits that you're dealing with. I know I've seen some textbooks where they try to justify that the limit at a certain spot's infinity, but I'm going to stick with the definition that if they don't converge to a specific point, then that limit does not exist. All right, so the function at -7. When x equals -7, the function technically lives at 1, 2, 3. So 3 would be the function's actual value at that spot. All right, now there was a bunch going on to these notes. You see the notes from the Google Classroom packet. I have Q, R, S, T, I think maybe a U and a V as well. Let's just stick with the Q and the R at this point. So I talked about the limit as x approaching positive infinity. Sometimes students get really confused because they see the asymptotes as representing positive and negative infinity when they don't realize that we're actually talking about x values. So the x value, it's when x keeps going to positive infinity, or it just keeps going to the right, what is the y value? How is the y value behaving in this graph? Well, here are the y values. It's the only spot in the graph where the y is actually existing. So if we keep going to the right, to positive infinity, they just keep going down and down and down and down. And they just keep forever going downward. So what is the y value as x approaches infinity? Well, it's forever going downward. It's not maybe going downward as steep as the asymptotes were, or at least the functions that were side by side with the asymptote, but this one, it's heading to negative infinity as well. So you would say, as x approaches positive infinity, the y value is approaching negative infinity. All right? So then if we're talking the opposite direction, when you go forever to the left, we can only be talking about the function that extends forever to the left. So this part of the function is not really going left at all. This one kind of stops here. This is the part of the function that we need to take into consideration. The one that goes forever leveling off at this horizontal asymptote. So, as you keep going left, it is never going to go below y equals 1. So what's the y value at negative infinity? Well, it's approaching 1. All right. I'm actually just going to stop the video right here and then try to determine if I want to make one on the second example or just provide the results on Google Classroom. We will talk about continuity at a different time. All right? We will not talk about continuity in this specific video. So, yeah, good luck with this stuff. Guys, this is brand new and it's kind of confusing, and I get it. You guys are kind of furloughed right now. You're having to do this on your own. Please just communicate with me when you don't know what you're doing. All right.